All right, so our last section or our last level for solve by factoring is when we have a story problem. And so for advanced, the main thing is we just have to create a quadratic by first drawing a picture and then figuring out what our quadratic equation would be. So notice that it tells you that a length of a photograph is 3 centimeters less than twice the width. So let's draw ourselves a picture. So here's our photograph. And it tells us that the length of the photograph is 3 centimeters less than the width. So if this is my width, the length is going to be 3 centimeters less than that. So it would be x minus 3. And then it tells us that the area is 54. So the area of my whole thing is 54, which remember that would just be length times width. So if I do the length times the width, and I set it equal to the area, I now will have a quadratic. So we have x squared minus 3x, if I do distributive property, equals 54. And I want it set equal to 0. So I'm going to subtract my 54 over so that I can get an equation that looks like our normal quadratic. So x squared minus 3x minus 54 is equal to 0. And now we're back to where we were in the last section, which is we're going to factor. So we're going to go 1 times negative 54 gives us negative 54. So our factors of 54 are 1 times 54, 2 times 27, 3 times 18, let's see, and then 6 times 9. So as we're looking, we're trying to figure out how we're going to get a 3 in the middle, and it's a negative 3. So the easiest case would be using 6 and 9, and our 9 would be the negative. So 6 subtract 9 gives you negative 3, and 6 times negative 9 gives us our negative 54, so it checks out. And so now whether you do box, whether you do grouping, whether you notice that because it's a 1, you can go and do it the fast way, which would be x plus 6 and x minus 9. We get 0, and then we'll set each of those equal to 0. And so we'll do x plus 6 equals 0, x minus 9 equals 0. And if I solve, I'm going to subtract 6 from both sides. So x equals negative 6. I add 9 to both sides, so I get x is equal to 9. And so now we've solved our quadratic like normal. But as we're looking, remember that what it's asking for us is find the dimensions of the photograph, which means we want to know like how many centimeters each side is. And we can't have a length be negative, so this doesn't make sense. So we're like, okay, this one doesn't make sense. So x equals 9 is fine. And so that would mean that our width is 9. So if this is equal to 9 here, then this would be 9 minus 3, which would make our length be 6. So then our answer would be that the dimensions would be 9 centimeters by 6 centimeters. And so this would be my answer. And again, this one works nice. The only reason I can jump there is because there was a 1 in front. If you're still not familiar with that, or you would rather check it by doing the box method or grouping, feel free to do that. As we look at example 2, same idea. It says you have the dimensions of a rectangular garden were 7 feet by 12 feet. So again, drawing a picture is always a great idea. So here's my garden. And it says the garden is 7 feet by 12 feet. All right, and it says each dimension was increased by the same amount. So that means we're going to increase it or add the same amount to each side. So I'm going to add x to each side. We can pick whatever variable. I just chose to do x. And now it tells us that the new area is 126. And remember, area is length times width. So I know, whoops, we'll wait for that a minute. So we know that we've got one side, which is x plus 7. Our other side is x plus 12. And we know that when we multiply them together, that's equal to the area of 126. And so we're going to multiply, whether that's distributive property, or if you like the area model where you draw the box, that's fine, but we're going to get to that point. So we have x times x, which is x squared, x times 12, which is 12x, 7 times x, which is 7x, and then 7 times 12, which is 84. And over here on the right-hand side, it just stays 126. So we're going to simplify. So we have x squared plus 19x. And then I'm going to subtract this 126 over to the constant so that I can do that kind of in one step. And so in my calculator, I'm just going to go 84 minus 126. And so that's my negative 42. And so this is equal to, or not equal to, I guess, minus 42. And then that's equal to 0. My idea is I want this to be 0 on the right-hand side. And now I'm back to where we can factor. So we've got 1 times negative 42, which is negative 42. And then our factors are 1 and 42, 2 and 21, 3 and 14, and then 6 and 7. And I'm trying to figure out how I'm going to get 19 in the middle. So 2 and 21, and if it's a positive, then I want this little guy, I want the 2 to be the negative. And then again, I can either do grouping, I can do box, or I notice that I have a 1 in front, which means we can jump to our factors really quick. So x minus 2, x plus 21. And then again, we're going to set those equal to 0. So if I have x minus 2 equals 0, x plus 21 equals 0, this would make it so I'm going to add 2 to both sides to get x is equal to 2. Or I can subtract 21 from both sides to get x is equal to negative 21. Again, the question is asking us find the dimensions of the new garden. So I want to know like what the length and the width is of the new garden. And so again, I can't have x being negative because negative 21 plus 7 is a negative length. And so this one doesn't work. And so now we can plug in our 2. So if we take our 2 value here and we put it in where 2 is, or where the x is in each of those, that makes it so that my dimensions are 7 plus 2, which would make 9. And if I put 2 in where the x is, up here,